Welcome to my channel RLD Academy. This is lecture number 9 on two ports network. In this video, I am going to discuss cascade connections of two ports network. Here we'll consider two ports, port number 2 two ports network. Okay. Here we'll consider this one port number 1, okay, of network A, and this is your network B, right? So this network A, this voltage I'll consider, I'll call it V1A, and entering current I1A. For this one, this is V2A, and entering current to this one is I2A. Okay, and this network we can define by its T parameters. So that T parameters are suppose TA. Okay, all the 4 parameters, this is matrix, 4 elements are there. So in short we write TA. So you know that for this one we can express this, okay, B1A, I1A, we can write as TA times B2A and minus I2A. So be careful about this one because negative sign is important here. Okay, so this is for network A. Similarly for network B, we can consider this is your B1 port number 1 B, this one is I1 B, this is your B2 B, and it is your I2 B. Okay, so its T parameters, suppose it is TB, right? Then we can write that V1B I1B equals to this TB times simply this B2B and minus I2B, right? Now we are going to interconnect these two. We want to connect these two networks one after another. So this one will connect it, and this one also will connect it, right? Then this total one, okay, this total network for this one, right? I want to get equivalent T. What is the T equivalent? That is the question, right? So here for this total network, this is your port number 1, I'll call it V1, and this incoming current is I1, and this is your V2, and this current is I2. Now we'll try to relate these variables, all the variables, right? So you can look at here, okay, this is I1 and I1 is same, V1 and V1 is same. Okay, so in a group wise form I can write that this simply V1 and I1 this column vector then should be same as B1A and I1A, right? And now this one in the middle here, what you will get, what are the two equations? So B2A and V1B is same, and I2A and I1B opposite. So minus I2A, I can write I1B. So these are the two equations here that we can consider, that B2A equals to B1B and minus I2A equals to I1B, right? And similarly here you can see, so this from this end, this I2 equals to I2B and V2 equals to V2B. So just we can write I2B equals to I2 and B2B equals to B2, right? So if we start from here, V1 I1 equals to B1A and a B1 I1A. So that we can replace as, so you see this one we can write as this TA times V2A minus I2A. Okay, now this I can make one vector here and I can make vector here, right? So this V2A minus I2A, I can write V1B and I1B, I can replace. So this one I can replace as TA and it is V1B and I1B. And again from here V1B I1B I can replace by this one TB times this one, right? So that I can replace. So this is your TA. Now that one I can replace TB times B2B minus I2B. Okay, so now you see this one. So it is TA, TB, and this V2A equals to V2 and I2A equals to I2B equals to I2 simply. Okay, so you see this left side I can write as V1 I1. Okay, so this is the equivalent T that we can form. So okay, minus sign will be there, sure. Okay, because it was minus I2B. Okay, so it is same form. So thus the equivalent T network, I can write T equivalent equals to TA and TB, the product matrix multiplication of TA and TB, right? And then you will get T equivalent. So this is the outcome. So if you take two network cascading mode, then total equivalent T parameters will be T equivalent equal to TA times TB. Just take matrix multiplication of TA and TB, right? Okay, next class I'll give you one example of this cascade connection. I hope you have enjoyed this lecture, and if you enjoyed this my video, then you can subscribe my channel, and to subscribe my channel you can press the subscription button, and then don't forget to press bell button, because then only you will get immediate notification of my future videos. I hope you are going to subscribe my channel and keep watching my videos in this channel. I'll be uploading lots of videos here. Thank you.